Hello students, welcome back to the fourth video of this playlist. So in this video we will be solving the fourth question from May 2024 P1 paper. So let's see what's the question number 4 is about. So basically question number 4, the concept behind question number 4, it's from chapter number 2, that is quadratics, from P1 textbook. So in order to be able to solve this question, definitely you have practiced problems from chapter number 2 of your P1 book. So let's get started with question number 4. Okay, so at first the curve C1 has equation y equals to x squared plus kx minus 9. Okay, fine, we know the equation for curve C1. And another curve, that is C2, has equation y equals to negative 3x squared negative 5x plus k, where k is a constant, given that C1 and C2 meet at a single point P. Okay, C1 and C2 are intersecting each other at point P. That means point P is a common point on the curve C1 and C2. Okay, so the first question asks at part A, show that k squared plus 26k plus 169 equals to 0. Okay, fine, we need to show that this equation. Okay, now consider the hint. The hint here is that C1 and C2 intersects at a single point P. Okay, when two curves intersects at the same point, we know that at that point their xy value will be equal. What do I mean? The x value for this equation and the y value for this equation would be same as the x value for this equation and the y value of this equation, right? That means at point P their y values, we can equate their y values equal, right? So what we can write, at point P the two y values are equal, so we can equate them. X squared plus kx plus 9, x squared plus kx plus 9 equals to what? It is equals to x squared plus kx plus or minus 9. This is equals to negative 3x squared negative 3x squared negative 3x squared and negative 5x plus k, right? Okay, look, now what we need to do, we need to take all of the terms on the same side. Fine, so 3x squared negative 3x squared, if you take it to the left it would become what? 4x squared, because there was an existing x squared. Then plus kx plus 5x, okay, plus what? Minus k minus 9, right? So minus k minus what? 9 equals to what? 0. Fine. Okay, now what we need to do, we can take, like, let's represent it in the form of quadratic equation, that is ax squared plus bx plus c. Okay, so k plus 5, this is b, isn't it? Since it is the coefficient of x, so that would be b, and you can write it here plus negative 9 negative k equals to what? 0. So we got an equation, that is a quadratic equation in form of ax squared plus bx plus c. Okay, so they said, are we done? No, we are not done yet, because we haven't got the required equation yet. They said the two curves intersects at a single point. That means, what does this equation represent? This equation represents the points of intersection between the curve C1 and C2. So the solutions to this equation would be the points of intersection, the x coordinate for the points of intersection, since the solution gives us the x coordinate. So if this equation has no solution, then there will be no points of intersection between the two curves. if this equation has two solutions, then there would be 2 points of intersection between the two curves, and if this equation has only one solution, that means there will be only one point of intersection between the curve C1 and C2. So here they said the two curves meet at a single point. That means this equation has how many solutions? Only one solution. Okay, so consider the discriminant. For one solution, we know that b squared minus 4ac equals to what? 0. Fine. So what is b here? The coefficient of x. That means k plus 5 whole squared minus 4 times a times c. So 4 times c. C is what? Negative k, negative 9. Fine. This is equals to 0. Okay. So now expand the bracket. So k squared plus 2ab plus b squared, that is 25. Okay. So 4 times 4, that is 16. So negative 16 times negative k, that is plus 16k. And then what? Plus what? 16 times 9. This is what? 144 plus 144 equals to what? 0. Okay. Now simplify this equation. What you will get? K squared plus 10k plus 16k, that would be plus 26k, and then plus 25 plus 144, that is nothing but 169. Okay, 169 equals to what? 0. And this is the required equation, right? So this is exactly what they have asked for. Done. Next, for part B, hence. That means we need to use the previous workings to find the coordinates of P. We need to find out the coordinates of point P. Okay. So for finding the coordinate of point P, at first we need the value of K, right? Since K is unknown. So let's find out the value of K using this equation. So if you want to solve this equation, how can you solve that equation? You've got 169. 169. So we know that 13 times 13, that is what? 169, right? So k plus 13 whole squared, it is equals to what? 0, right? Because k squared plus 2a, like 2 times 13, that is 26. It's exactly matching this expanded equation, right? So k plus 13 equals to what? 0. So you are getting a single value for k, that is k equals to what? Negative 13. So we got the value for k, right? Now what we need to do, we need to substitute the value of k into what? The equation for solution. What's the equation for solution or equation for roots? This is the equation for the roots. Okay, this equation represents the solutions, like the points of intersection between the curve C1 and C2. So let's put the value of k in this equation. So what you will get, if k equals to 13, negative 13, so you will get the equation for x squared plus k plus 5. Okay, k is negative 13. So negative 13 plus 5, that is negative 8x. Okay. So if k equals to what? Negative 13. So you'll get 4x squared negative 8x, and then 4x squared negative 8x, negative 9, negative 13. That means negative 9 plus 13, that would give you plus 4. Okay, that is plus 4 equals to 0. Okay, so 4x. Now what we can do? We can divide both sides by 4. So we'll get x squared negative twice of x plus 1 equals to what? 0. Okay. X squared negative twice of x plus 1 can be written as what? X minus 1 whole squared. So what you will get? X equals to 1. Okay. Okay, x equals to 1. So at point P, we got the x coordinate of point P, right? So at P, x equals to 1. So we got at P, x equals to 1. So what would be the value for y? Just wait. X equals to 1. So we got the x coordinate of point P. So you can put this x coordinate in any of the equation of the curve, okay, of the two curves, because point P is a common point between the two curves, so you can put it in any equation. X square plus kx plus minus 9. So if x equals to 1, what would be the, and k equals to what, -13, right? K equals to -13, so y would be what, 1 minus 13 minus 9. So 1 minus 13 minus 9, that is -22. -22 plus 1, that is -21, right? So the y coordinate of point P is what, -21. So we can put it in any of the equation. So we'll get what, 21, -21, right? So point P has coordinate what, 1 and -21. And that's all about the fourth question from May 2024 P1 paper. That's it.